Hi, everybody. I'm Mike Moss, Wally Oladitin, and Eric Lowe's. Wally's from AWS IoT, and Eric's from VIZIO. I'm from Alexa. We're going to kind of gang up to give you some insight into smart home. How many people here have some familiarity with smart home or how it works? Okay, not everybody. That's good. My purpose in this is to kind of give you some background on smart home. I'm the evangelist for smart home, so I should know a thing or two about it. I'm going to try and get you from 0 to 60 with smart home and some smart home background. I'll show you some things that Eric will expand upon and talk about kind of real-world use cases for, and I will then talk about a demo and resources. So I have something to show you and some tools that you can actually use to play around with this stuff in your own developer accounts. Again, Eric will talk through some of VIZIO's journey through that, and then Wally's going to wrap up with some super cool AVS stuff, including some of how AVS and even smart home skills can work together, which is awesome. Okay, the Alexa Skills Kit. When you're building any type of skill, including a smart home skill, you're going to use the Alexa Skills Kit in some way. It is the tools, documentation, SDK, all of really the content that we need to help you build a skill. It's the developer resources that you have, and we keep adding to them all the time, including the source code, sample code, the SDK revisions. In the last year, I can probably think of at least 20, if not more, significant updates that we've made to the skills kit and the tools that you've used in it. If you're interested in it, developer.amazon.com/ask. Oops. There we go. There are lots of different skill models out there. Predominantly, the ones that you see, like the Jeopardy skill, Magic Door, all of those are custom skills where they have an invocation name, ask, or Alexa, open the Magic Door, or Alexa, open Jeopardy. There are other different types of skills and models for them, but the ones that we're going to talk about today predominantly are smart home, and these are invocationless in that we understand that you have a device. You've registered a device into your account, and that we can actually control it, or you can control it through Alexa. What that looks like in general is something like this. You've got an Alexa cloud in the middle that controls a lot of things like, obviously, speech recognition. When you talk to her, she interprets what you're trying to say, but also incorporates things like machine learning, right? So if you say something slightly ambiguous, we can look at what other referential or contextual information you have. Like if you say, turn on the light, you happen to be speaking to a device that's in a group that has a light, we can do things like turn on a light within that group via implicit targeting. Things like natural language understanding. Obviously, if you give complex utterances, or even if you craft them, for example, in a custom, we can tear that apart and try and understand what you're doing with things like dialogues and slots, and try and allow you to create an utterance that can map to your customer's needs. And then finally, text-to-speech. This year we introduced, or kind of exposed Polly and the ability to use Polly voices within Alexa, so you can come up with other voices other than just Alexa's default voice, or if you don't want to use your own MP3 or audio files. Okay, some smart home capability interface examples. When we talk about smart home, we're really talking about what capabilities do you want to introduce with the device that you're selling or providing to your customer. The easiest example, maybe for a TV, is like, for example, the second one, Alexa Power Controller, right? Turning on or off a device. If I say, Alexa, turn on the TV, right? In my profile, under my registry, I've registered a device, most likely by going to maybe the VIZIO skill or to another manufacturer's skill and incorporating that skill within my Alexa app. At that point, I've identified a TV and I can address it by name. Whatever capabilities have been appropriately set on that TV is how you interact with it. So things like turn off, turn on are common, but there's also one which isn't up here called the input controller, which allows you to set things like change the channel or even go to name channels. Some other examples on here, color controller. So I can change and report on the color. So for example, if I said, Alexa, turn the light to blue, right? That light as an endpoint, as a device, has a capability associated with it for color control. It may also have power controller, right? Turn on the light, turn off the light. So these capabilities are layered together into an endpoint to define what it does. And you can kind of pick and choose for the device that you want to build or you need to expose to your customers, and Alexa will handle all of basically the heavy lifting for the voice and natural language understanding. Another benefit of this approach, other than just not having to do an invocation, is localization. So you don't specify turn on or turn off. You don't necessarily have control over what those invocations are, but you also don't have to localize them. So if you build an endpoint and are properly associated its capabilities with what it needs to do, you can also release that in all the languages or language areas that we currently support, like Japan and the UK and even Germany. Okay, so these are what I would call our specialized interfaces. They're things like, for example, the thermostat controller, where we have an opinion and we think we know how to actually control the base functionality of what most of us would consider a thermostat, right? Setting a high, low set points for temperature, getting and reporting state of what the temperature actually is, and a few other controls that are on it. However, we've just recently announced some new capability interfaces, and these ones are much more generalized. They represent, if you will, just think of the front of a device, the buttons and knobs and switches and functionality that you would want to expose to your customers. The first one, the mode controller, is really just a single value selected from a group. So you can imagine in the case of a fan, you could have a ordered mode of high, medium, low. Or I should go low, medium, high if you want, whichever way you want to go. That's an ordered collection. You get to select one of those, and that in turn can set the speed of your fan to whatever you want it to be. It can be unordered. So if you think of like the front of a washer, where you have normal, delicates, heavy, cotton, whatever, you select one of those. They aren't necessarily in any particular linear order. They don't have a range, if you will, but they can be selected as one value. The next one is a range controller, and this is really any numeric value within a range. So it could even be time, temperature, speed, any value from 0 to 10 to 1 to 100 to, I think, even like negative numbers to positive numbers, you can specify. Another interesting thing about range control is, with some of the new functionality in these interface examples, is that you can specify named values for specific values within your range. For example, a toaster. If you have a toaster that has a heat setting from 0 or 1 to 6, you can go in there and say, in your capability definition, when I describe this device to Alexa, I can say things like 1 is light, 3 is medium, and 6 is dark. And I can have those utterances be understood by the device control to actually represent those values. So I can say, for example, Alexa, set the toaster to dark. And what happens is you really, under the covers, get a range controller response that actually sets that value to 6. And you get to define those. And if you do it well, you can actually pass those on to your customers and have them control that through their own interface. Excuse me. Finally, the toggle controller, which is really just a switch, on or off. Can be on or off, doesn't have to be on or off. Could be things like bagel mode, not bagel mode, right? It's just a yes or no, on or off, enabled, disabled, one state, other state value. And you can use that for whatever you want. The final thing I'll mention about these, unlike the generalized interfaces, you can define multiple of these per endpoint. So in the generalized interface is like if you added a thermostat controller to an endpoint, you could only have one. Didn't really make sense to have two because you'd have to figure out how to route it and all that. But with this, you can actually say, you know what? I have 2 sliders, 2 range controllers, 2 ordered modes, and even a toggle controller or 2 on it. And you can just create them and give them what are known as instance names that you can identify. And then when it's reported back to you, that's given as like, the customer said to turn on this particular range with this particular instance. Okay, let's talk about endpoint cloud architecture. We've talked about what endpoints and kind of how the capabilities are created for those. I thought that was me. But let's talk about what this might look like. So I tend to think northbound, southbound. Northbound on the top side here with the user. It's hard to read here, but this is the home network on the top, and then the network, the net, the cloud, whatever, wherever else you're storing this logic. Typically what happens is the user gives an utterance that goes into Alexa, right? She's listening, she takes that, sends that into the cloud. All smart home skills have to be account linked. This is because what we need is an access token that gives Alexa authority to act on your behalf for a particular customer. So for example, if I go in and link my Philips Hue skill or my SmartThings skill or whatever, at some point I authenticate with Samsung and get an access token that's handed to Alexa so that when an utterance comes in, like turn on the light or turn off the lights, that can flow through the Alexa cloud and is delivered as directives and events. Excuse me, delivered to your skill service as a directive with a response coming back as an event. So in this architecture, right, we have kind of this amorphous endpoint cloud that's servicing whatever these devices out here. They might be TVs, they might be lights, they might be whatever it is that you actually have in the customer's home. But down here we have a Lambda that's required to service the skill request. So as a directive comes in, you unpack that and actually send that out to your endpoint cloud to do whatever work you need to do. Now, a lot of companies, and even there's a lot that don't, but a lot actually just use AWS as that endpoint cloud, right? Where you can take services like DynamoDB, AWS IoT, and use that to store information, obviously, about the state and properties of these devices, but then also API gateway to maybe rationally expose how to control or modify these devices, and then even another Lambda here that's actually providing services for the API gateway. Okay, so we've got a flow basically of utterances come in, go out and do things for the user. We have account linking that goes off to log in with Amazon. You can use others. Eric might mention one. But what that looks like in terms of AWS Service Architecture is something like this. So we have the Alexa smart home skill, right? The device that maybe is accepting the utterances and sending them off to the cloud. But all of this, at least in the example, the resources that I'm providing, are all wrapped up in a CloudFormation template, so you can drop it into your environment and create a little sandbox for testing all of this stuff. Using things like AWS Lambda, obviously, for handling the skill service, but in the API gateway interactions. Amazon DynamoDB for storing what I would call kind of non-critical information. So if you have a device description or some other relevant matter about a device that isn't necessarily state property that's going to change all the time, you may want to store that in DynamoDB while you store property or actual state on AWS IoT in a shadow. And the reason I point that out is for when you do things like discovery, when I go out and ask the customer, or the customer asks to discover devices, for example, Alexa will go down into that skill and say, hey, what devices do you have? At that point, it's the onus of the endpoint manufacturer to create a discovery response that lists them out, provides all the capabilities, and correctly responds with all that. And what you could do on the endpoint side is basically say, well, I have all these devices in AWS IoT, but I can pull all this information from DynamoDB, meld that into a JSON response, and send that back to Alexa. Okay, so let's take a look at a demo. HDMI 2? Hope so. Okay, so the first thing to note is GitHub. There is a repo out there that has some very serious instructions on how to actually set up basically your own endpoint cloud, where there's a lot of information to collect. You actually have to do stuff. But if you could just go to github.com/Alexa and search for IoT, there's an example called Skill Sample Python Smart Home IoT. Really, like I mentioned, behind the scenes, it's just a CloudFormation template. And I do it that way because there's just too much to set up. And going through the manual instructions takes forever, and it's error-prone. So there's things in there like the outputs where we have now an API endpoint that we can use to do things like control the endpoints, send events, and so kind of some other cool tricks. So those services, like the API gateway, well, first of all, we start with IAM. That's another good reason to use CloudFormation, is that you can dynamically build all your policies and really lock things down without having to do it again and again. The skill adapter, in this case, is a Lambda that really is just a proxy. It passes through whatever directive comes to that skill. It will pass on basically to the API gateway. It formats it into an API messages and forwards it to a directive endpoint. And you can see that here we have 3 endpoints: directives, endpoints, and events. And what that really says is I can create new endpoints by sending posts in, I can handle directives in this directive endpoint, and then I can handle events like, for example, proactive state updates or endpoint management. So the API demo, what I'm going to do is use Postman to populate, right? I'm going to post a black sample switch example with some definition of what I want it to say to my API to create this endpoint in my database, essentially, with capabilities that I define, and I'm going to pass those on, and I do a send, and I get a 200 back. In previous outings, you'd have to discover. Now, it pops, because you can use proactive endpoint management to send an out-of-band asynchronous request to the event gateway and have a device immediately show up in your device pool. There's no, hopefully, from this point on, you won't actually have to say Alexa discover. You still can, and it will still behave the same. It'll still go back out and ask for those devices. Okay, so the thing endpoint demo. So now I've created a black switch. It doesn't really exist, but I've got a thing reference for it that now also maps to, in this case, it has state, it keeps track of the user ID, but it maps to a DynamoDB entry that keeps track of other information. So I think I switch over to that here in a second. One other thing. So one thing that I do that I cheat with, so we have an entry here, is I just dump the capabilities as JSON into DynamoDB and sort it out later. Sometimes I just extract it and pass it straight on to Alexa. You can deal with that however you want. Really, Alexa is just kind of advanced JSON manipulation, honestly. In my smart home skill, there is a pointer to the skill sample adapter, which again is just basically a proxy to the API gateway that handles all the requests. A lot of people do this to help get through certification, by the way. Black sample switch shows up in my device list. I didn't have to say Alexa discover devices because once I pressed go on the, switch this back here. Once I pressed go on the Postman, that post basically created the device, added it to IoT, added it to DynamoDB, and then sent Alexa an event that says, hey, there's a new device. And realistically, you'll pull out your phone, you'll get a pop, it shows the device. If you've played with or bought the Amazon Alexa microwave, it also kind of does that same pattern. Okay, key points. First off, API gateway. This is really a toy example. You're going to probably have your own front end. You might even have your own existing content management service. But for example, if you're tracking thousands of devices for customers, how you extract that and represent that in JSON to Alexa is really the task, right? So I have 1,000 different users with 100,000 different devices. I have to figure out a way to pull all that in when Alexa asks into a JSON file that then is going to describe what those devices are. Lambda, in this case, is really just a logical router, right? It's the compute. It figures out, hey, this directive that's coming in is a discovery. I need to handle it this way. It's a power request, or hey, they're asking to change a range, or a range has been changed. It really depends on what it's for, and that's what the Lambdas are excellent at, is just deciding what to do next. AWS IoT in this example is the state arbiter. So from Alexa, if I say turn on a state, turn off a state, that ultimately gets pulled down into the IoT device and represented in the thing shadow. And AWS IoT is great for this because of things like Greengrass and being able to use MQTT to basically interrogate state also from the device. So you can set desired state and negotiate what state devices should be in actually from the device themselves. And then finally, the Amazon DynamoDB, I won't harp on it, but that's where you store kind of your long information, so things that don't necessarily change too much. Okay, so we've taken a look at the infrastructure. I think it's time now for Eric from VIZIO, and he can kind of talk to you about VIZIO and why this is important. Thanks.
All right, hello everybody. So I'm going to talk a little bit about how we integrated Alexa and IoT into our televisions and soon-to-be soundbars. So for you that don't know, VIZIO is a leading smart TV brand in America. We believe the TV's role within the entertainment ecosystem needs to evolve to keep up with the ever-changing landscape. The TV needs to function as another connected device in a consumer's life where content can be enjoyed in a variety of ways. So we're really focusing on delivering our promise to continually bring new value to the consumer. 3 years ago, we brought SmartCast OS to the production. It brings popular apps to the TV screen for easy access, serves as the ideal smart home companion with voice support. The platform has been designed to serve as the ideal smart platform for everyone, from those looking to just easy browse, to cord cutters, and to smart home enthusiasts. We've taken control of the TV a step further by incorporating Alexa voice control, allowing users to control the TV without lifting a finger. When we began working on this, SmartCast IoT requirements. Number one, we're looking to secure highly scalable, low-cost cloud infrastructure. We have millions of units in production, so we need a secure and highly scalable solution to handle our number of inputs, and of course, it has to be low cost. Number two, we need a high availability, low latency cloud device control and telemetry. We have many moving parts to send commands to a TV. You'll soon see that in this presentation. We need a reliable and fast connection to deliver these commands. Number three, small embedded device footprint. These TVs have limited resources, and any IoT integration needs to use limited resourcing. At the end of the day, our resource allocation cannot affect our general use of a television, which is simply to watch TV. Number four, interfaces for popular development frameworks. We need a solution that is widely adopted, has multiple SDK and framework and platform support. This allows us to move out of embedded development, allowing us to have quicker cloud-based deployments to deliver new features to consumers faster. For us right now, a firmware release cycle takes anywhere from 4 to 6 months. It's painfully slow, and the more we can do in the cloud, the faster we can get support out to our customers. And number five, the roadmap of complementary services. We're looking for a service that has continuous development and is aligned with our features and works with us and not against us. We're looking for something that builds additional features such as device analytics and customer service features as well. So with that in mind, with our IoT applications, what we have found is AWS IoT is an open and scalable solution that allows the flexibility to drive many different types of applications. Our first goal was an Alexa integration that we launched this past spring. We are particularly focused on sending commands to device due to time constraints. This fall, we're releasing additional AWS IoT features, including two-way communication, our device management, and device shadow support. Those integrations this fall will allow us better contextual support with voice integrations, something that Mike was talking about. It's a little bit of a linguist nightmare sometimes to try to do a command to these TVs. By supporting contextual support through the device shadow, knowing when a device is turned on, off, whether it's playing content, can help solve some of these contextual problems and allow the user to send a shorter command. Also with device analytics, this is something that we're super excited about. We're gonna have real-time event-driven data that'll help us make better business decisions on how to better support our customers. Okay, so you saw Mike's slide. This is a little bit of how our infrastructure is laid out within AWS. For our initial integration and for our prototype that we got up in about 3 to 4 days, we really focused on IoT and the Lambda for the smart home skill Lambda service. We ended up going with a Python SDK on our TVs that was integrated into our web service. When SmartCast was initially launched, we had a companion applications called SmartCast Mobile that allowed you to do command control on a LAN network. So we already had a web service interface sitting on the TV that allowed any mobile application designed by VIZIO to control the device. So when we integrated the Python IoT SDK, that really just enabled us to send or have another protocol to the service that was already designed there. So every API that we already had on a LAN network, within a matter of days, we could control from remotely. So after we had our prototype, we kind of got then into more of what we're calling our device management service. And a lot of this is what Mike was referencing. So we have a Lambda that is for our APIs, and a lot of the DynamoDB is holding that state. One thing that we ran into is device name change, right? So we had to update the device name change to our DynamoDB and then do the Alexa discovery command to update that. If anyone did that, we found that out, is without the discovery command, then obviously you couldn't route to the correct TV. As we built out the device management service, think about account linking and device relationships and what that means. Knowledge of what voice features are enabled. So we have multiple voice solutions leveraging our IoT connection. And also security verifications. We're now exposing this TV remotely, and we need to make sure that we do our best to make sure it's 100% secure. And after that, it also allows additional VIZIO services now to interact with physical devices. So before, as I mentioned, SmartCast Mobile was purely on a LAN network. But now with this IoT connection and our exposed APIs, we now have a remote connection so that we can build additional feature sets for when you're away from your TV and can start to be notified potentially if someone's on the TV, maybe your kids are watching too much TV and you turn the TV off remotely. We can build some of those parental controls in now, and you can control your TV remotely with IoT. So why AWS IoT? From the very get-go, we had great consulting. We still have great support. They want to work with us. They understand our challenges, our needs. The roadmap of services really help to continue to push our new features, our data and processing in the cloud, and makes the device more simple by leveraging the power of the cloud, shortening our development cycles and releasing features faster to our consumers. And that really aligns with our VIZIO strategic vision of our customer value to them. And with that, I'll introduce Wally, and he's going to talk about adding voice and IoT.
Great. Thanks, Eric.
Thank you.
Awesome. So I guess I'm standing between everyone and beer, but hopefully this is even more enjoyable than a pint. We've heard a lot about smart home skills, AWS IoT. Just to get a sense, how many of you used AWS IoT? Playing around with AWS IoT at all? Oh, okay. Great, this is fantastic. If you're not familiar with AWS IoT, I'll kind of talk about Alexa first and AVS and some integrations there. But with AWS IoT, what we basically support is a bidirectional communication channel over MQTT, which is a lightweight IoT protocol. The nice thing with MQTT is when you start using AWS IoT and AWS IoT Core, that's our broker, you can use that same bidirectional channel with other applications. So you can do things like run a persistent MQTT channel and do HTTP, HTTP2, all these other things can kind of run in parallel along with AWS IoT. And so we start thinking about kind of taking the aspects of voice and then expanding them further. We've done a lot of the kind of, enabling Alexa where you're using an Echo, right? So if I'm in my home and I'm able to have an Echo here, I can speak to it and then, in the case of VIZIO, kind of turn on my TV. But there's also a lot of cases, interestingly enough, in IoT where people want to bring the voice experience onto the product itself. So you can think about building automation. So I'm in maybe I manage an apartment unit and I want to be able to walk into an apartment unit, not have anything kind of displayed, maybe not an Echo, like something that's specific to my building, and say, get this building ready for show. I want lights to turn on, I want the temperature to be set to something, I want the blinds to come up, and then when the tenant walks in, my unit's ready to show. Even in industrial settings, you're working with equipment, your hands are full, but essentially it may not be a dot, you want something ruggedized, you need something resistant to temperature and heating. So how can you basically take the aspects of Alexa, the voice aspects, and start expanding it into products that may not be just the Echo? And this is where Alexa Voice Service comes into play. So when we talk about that kind of IoT aspect, we say, well, how can we move some of this onto the device? AVS is how you bring the voice onto to the device. With AVS, what you essentially do is you have a SDK running on the device that instead of communicating through to your cloud and then to the Alexa cloud, with AVS you communicate directly from the device to the Alexa cloud directly for communication for voice aspects. And because this happens over an HTTP2 channel, what I talked about before with AWS IoT, I can run MQTT as another process on that same AVS device, or I can run it essentially as one full firmware application. With the AVS integration, the same things that Mike talked about, directives and events, still apply. But again, we're not going through the cloud to do so. We're not going through your cloud to go to Alexa. So you can do directives to basically say, you need to tell a client to play an audio file, and here's the URL. That goes down to the device over this channel. And then vice versa, it can respond to events that Alexa's interested in upstream on a HTTP2 channel. But in addition to that, you can still augment that with AWS IoT. So all your telemetry information, what's my battery life? How long is this process running? Is it ready for maintenance or ready for a firmware update? All of this can be delivered directly to AWS IoT through that MQTT channel, again, while you're still enabling voice. So what do these integrations look like if you want to use like Alexa and AVS? So if you just want to use AVS, the main thing you need is just going directly to the Alexa cloud. You have your device, it has to have a mic array, so something that can take audio input, and a speaker to take audio output. But if you can do that, you can communicate directly to AVS and handle the kind of basic directives and eventing that we talked about earlier. You can have a smart home control, again, what we talked about when you have an actual physical echo, where you want to say, I've got a device, it doesn't have its own mic array yet or a speaker, but I still want to be able to control it. So in this implementation, the Alexa-enabled device communicates to AWS. AWS is the broker to turn around and talk to Alexa, and then vice versa. It can go in the opposite direction. Alexa says, please do something. It goes to the AWS cloud. It can go through IoT, through that persistent channel, and say, do something. If you do have a mic array and you have an audio output, you can also still combine the two. You can say, well, I want to do building automation. I want to control conference rooms. So someone walks in a conference room and says, please book this conference room, but it's through a VIZIO TV mounted on the wall and not an Echo device in the middle of the table. In that case, you can combine both. You can have AVS for some commands where you're interacting directly with that device, but you can still augment that with skills as well. You can say, I've got a smart home skill that allows me to turn off all of the TVs before I close the office door. So you can combine these two interactions where you have these two different channels, one driving your voice experience, and one driving your IoT and automation. So to pivot a little bit more on the IoT aspects, how can we start combining these voice aspects with the things we can do in IoT? So if we're communicating with Alexa voice service, so using AVS or again, smart home skills, we might be sending data directly there, but we want to send some additional telemetry to AWS IoT Core. So I mentioned it's an MQTT persistent channel, so once you connect to it, it's long-lived. You just need to kind of ping us every so often to say, hello, I'm still here, don't close my connection. But it's a long-lived one. As long as we see traffic, the connection stays. Through AWS IoT Core, when you publish a message, we have something called the rules engine. And the rules engine will basically look at a message, look at the topic that message is published on. And if you say, whenever something's published on Hello World, I need you to go here, it will send that to another upstream AWS service. So in this example, I'm using the rules engine to say, for operational metrics, I need to store all of my telemetry in Elasticsearch Service, which is a AWS service the rules engine supports just natively. So in this case, I want to do something like time series, right? If I'm doing operational controls, I need to know what happened to this device over the last 15 minutes. And Elasticsearch ends up being a great fit for that. In addition, though, we talked about these kind of other applications that you need to think about. So you might have, if you're in smart home, you almost always have a companion application. So if you're developing TVs or speakers, someone's got to be able to pull out their phone and do something with your product. Same thing again in industrial. If you're a field technician, you go out and you need to go support a valve pump. You might have temporary access and you're on a ruggedized like Windows machine, but you still have to be able to see a view of your device. So through that same telemetry channel, I can have a rule that listens to all of my shadow changes. This is my reported state of my device. And through that, I can then route it to DynamoDB. And if you're not familiar with AWS AppSync lets you just put a GraphQL interface on top of a data store. So now I can create a completely custom view for this end user, right? Maybe the end user doesn't need to see my firmware version. They don't need to see battery life and diagnostics, but my consumer really wants to know if their kid has been watching TV too long. So now I can essentially like give them the exact thing they want, send it to a different service, and have them have data that they need access to. The other more common use case as well is once you have voice enabled, it doesn't really end there. As Eric really alluded to, he's like, well, now we got a whole bunch of other stuff we want to do. We want to be able to have you do parental controls. We want you to be able to integrate with other services. So to do that, you have to be able to do the operational aspects for your devices. And this is another place where AWS IoT Core can really help you kind of integrate these services together. So again, I still have the same kind of 2 persistent channels, HTTP2 for my AVS integration, MQTT for AWS IoT Core. But now with the shadow, what I'm going to do is I'm going to make use of the shadow to semi-reported state, and then I'm going to enable what we have in AWS IoT device management, 2 features, and I'll actually demo this in a little bit. One is fleet indexing, which allows me to essentially turn every attribute inside of the shadow into something that's queryable, that I can search against. So I turn on fleet indexing. And then what I can also do is I can turn on another feature called dynamic groups. And what dynamic groups will do is you can define a query of the kind of devices you're interested in seeing. So in this case, I want to roll out updates because I've got a patch. And so my dynamic group has 3 devices in it currently, and my query for my dynamic group is whenever a device is connected, connectivity connected true, and the software is on version 5, that's the old version, I need you to take this device when you find it, and I need you to add it into that group. Now the benefit here is I've got some things that I'm already running with voice. I have a separate process for this MQTT channel, but now I can basically target this device for new features. And I can do this in one of 2 ways. So in the demo that I'll do, I actually do this manually. I'll be the administrator, I'll log in, I'll basically target a device, and then I'll have it update and move into a group. But with AWS IoT device management, I can take that same voice application and say, well, I just want you to auto-update. I want you to say, as soon as this thing gets dropped into this group, immediately deploy a job to it. So again, these things that I want to do for my devices that have this voice enablement, I can then just start adding new features over time. Cool. So what I'll do is I'm going to switch screens again. We did this session on Monday, and my demo didn't work the first time, but I recovered. So we'll see if take 2 is even better. Cool. So I mentioned AVS. So if a little bit bigger. So what's slightly different here is that I mentioned you have an Echo, you can essentially use a skill, no problem at all. The nice thing with AVS, it just supports a number of device SDKs, similar to AWS IoT. We want to get you started quickly. If you download the device SDK, you build it, then you can basically turn anything that essentially is running that SDK into a voice-enabled product, again, if it has an audio input and output. So in this case, I'm running the AVS client, but I'm running it from my machine. In addition, because we have a number of AWS SDKs, I basically coupled the Alexa SDK with an IoT SDK. So again, I mentioned you can run these as 2 separate processes, right? 2 persistent channels, they're not going to crosstalk. You essentially can throw data over one, you can throw voice over another. So to show what that looks like, I'm going to go into the AWS IoT console. I'll go to my shadow, and you'll see I just have like a little shadow counter, just so you know it's actually updating. So here in the console, every few seconds, I'm basically just sending a counter just to say, look, this is actually working. It's not just state that's super static. But I mentioned as well, like all of this metadata, because it's an AWS IoT Core, I can actually start driving my device behavior based off the fields here. So me as a product owner, I can say, well, I need to do updates based on this state. I need to put these into diagnostic mode. I need to do troubleshooting based off this information. So what I'll do now, since I have this state, so I've got a volume 7, I've got a software version 1.0, I'm going to look at this AVS Client, and what I'm going to do is I want to update the version to the new one. So it won't change the voice implementations I can have, but it will allow me to essentially add new attributes to this device. So one other thing that I'll show, so I have the dynamic group configured. The dynamic group has AVS connected device. This is the device that's running on my machine. And I've created this same dynamic query that basically says, you're a connected device, your value is true, and your software version is 1.0. So just so you can see the interactions, I'm going to quickly launch one more console. And what I'm going to do now, just so you can actually see that this stuff works, I'm just subscribing to notifications. So I mentioned we use MQTT. So if you haven't used it before, it's just a topic hierarchy structure. So right now I'm basically saying, hey, this voice is going to be interacting. I just want you to listen to it as it does its updates. So I'll subscribe to this one, and then this just lets me know that my process is actually complete. So I'll subscribe to this second one. So now this process is running. So the metadata is going to change, but I'm just going to show that I can continue to do voice as this update process is working. So last time I told Alexa to tell me a joke, but I think this time I'll tell it to tell me about AWS. So if it's with me, tell me about AWS.
Amazon Web Services is a subsidiary of Amazon.com that provides
beer's gonna be
on-demand
good.
cloud computing platforms to individuals, companies, and governments on a paid subscription basis.
It has our messaging down pat. But as you can see, I'm running the process. I don't have any appliances with me. I'm just running it just on this product. So I'll keep this process going as I switch screens really quickly. But what I'm going to do is actually do a deployment to that device. So I'm going to create a job for here. I'll create a custom job. This just allows me to just say, what do you want to deploy down to the device? In this case, I could select my dynamic group and say deploy it to everything in that group, or I can just target an individual device. And I'll target an individual device for this one. You select what you want that device to do. So as this deploys, I'll actually show what this job does, but because it's just doing configuration information, I'm going to keep the voice aspect continuing to run. I'm not going to kill the voice because it's got its own channel. I want to have all of the updates happen over MQTT. Click Next, and I click Create. This happens really quickly, but I'm just going to show you a few things. Again, this is a process running. It's still running, right? It hasn't really stopped yet. So if I wanted to say something else, tell me a joke. Why not?
Take it away, Jimmy.
What is a tree's favorite app? Sapchat.
There we go. So that's run. I did a voice implementation, but at the same time, because I've got this other channel, I've actually pushed a software update to that device. It's actually pulled down a configuration, unpacked it, added some firmware specific information, and then returned success. Again, over 2 different channels without impacting the voice aspect. And if I go to my dynamic group, I'll also even see, since I've updated that device's state, it's no longer in my patch 1 group. I said, hey, you're on an old patch. I need you to go update yourself to the new patch. Once you do that, you should be removed from this group automatically. And now I don't have to go patch this client. Just to close it out, I actually show you what that job document looks like that I'm actually sending down to the device. It's fairly simple. I'm basically saying I just want you to do an update firmware. And in this case, that firmware bucket that I have there, so it's not actually bucket/key, it's just my AWS IoT jobs bucket, it just pulls down a configuration file over MQTT. And then I say, go to version 2 of your firmware, and I need you to add some new features. They're not voice-enabled features, they're diagnostic-enabled features. So it adds a location and range, information and then start sending it to me. So if I go back to my device as well, you'll see inside of the shadow, it's now augmented some of its information at the very bottom. You'll see range and location added. And again, because these are two different channels, I can continue to use the voice and I can continue to add new features to my product, and each one can have a seamless experience. Cool. So hopefully that gives you some ideas of how you can start combining the voice aspects, especially on your products, with the IoT aspects. If you look at AVS, so if you say, I really want to have a device that has the audio input and output so I can essentially run my own voice on it, look at using other ancillary features like device management. It could be AWS IoT device management, but any device management. If you have a device and you deploy it, you need to go, how am I going to update this thing later on? I definitely don't want to walk there in person. You want to have a registry as well. Like, how do you actually store either static or dynamic state for your device? You can use AWS IoT Shadows, you can use a registry, you can use Dynamo. You want to have something that allows you to go look at this device and say, what state are you in? And from a security perspective, with AVS, you can have that second bidirectional channel, right? You've got one for voice and you have one for MQTT. With AWS IoT Core, I didn't dive into it as much, but it is over TLS 1.2 with mutual authentication and authorization, so everything's encrypted in transit. If you're using smart home skills, this list just grows a little bit. So all the things we talked about before, you can still use the kind of IoT aspects, device management, device registry, all the cloud security. But in addition, as Mike and Eric alluded to, you need some compute. Right? You're doing the cloud-to-cloud integration. You've got to go tell the Alexa cloud what you want it to do on behalf of this device. Just to give you an idea of all the kind of roll-up overall AWS services we talked about, if we kind of look at the bottom, the customer, you are the customer. If this is your product, you kind of have those two channels I talked about. You can go directly to Alexa over there on the left, or you can go through your cloud, then through Alexa. In all cases, you need that directive and event handling locally or in the cloud. And in addition, you need the secure bidirectional communication, again, either directly to Alexa or to the cloud. And if we were to roll up all of these individual services and what you would use for your applications, for all of the APIs and front ends, those are your Lambdas and API gateways. All of your user information, customer profiles, authorization endpoints, those are your login with Amazon, Amazon Cognito federated identities, or user pool identities. Then different variations of knowing who your user is. And for AWS IoT, I kind of show that OTA aspect. But again, these are the things that you need. So if you're like, hey, I don't want to use AWS IoT, we hope you find it really helpful and it gets rid of a bunch of undifferentiated lifting. But if you say, I want to do something else, you just have to make sure they do these 6 things. You need to make sure you can search for things, update devices when they're in the field, that you can store your telemetry, and you can have inbound and outbound communication. So just want to leave you with a couple of places of where you can start. So you're thinking, okay, I really want to do this, what's the best fit for me? If you're primarily in kind of a brownfield situation, brownfield meaning you've got a device, it doesn't already have a microarray, there's no way to speak to it or hear something from it, you'll end up doing a cloud-to-cloud integration, whether that's a smart home skill or a custom skill. If you're looking at something greenfield, if you're like, I'm really interested in tackling the industrial space or home automation or building automation, and I want to get into BACnet with voice and all this kind of cool stuff. If you're in greenfield, start looking at things like AVS. Say, I want to use AVS and IoT. And then you can augment that in the future with still cloud-to-cloud integrations. So in summary, I know we covered like a broad spectrum of things. Mike's dove into how you can get started with smart home skills, get used to like running his example client. I've actually run it multiple times. It's like really quick to get started. Then we heard from Eric really giving the story of VIZIO and how they started using AWS IoT and Alexa. And then you got stuck with me at the end between you and beer, but hopefully it was really good to hear how you can dive a little bit deeper with IoT and get used to using AVS. I'll leave these up for a little bit, but some just helpful resources, just some links we found helpful on the Alexa side and on the IoT side. I believe Mike's GitHub repo is somewhere in there, right? Right in the middle? Yeah, it's changed though. Oh, well, I wish I knew that. But hopefully it redirects you to the right place. And with that, thank you so much. We do want to hear your feedback, so complete the survey. Come chat with us. We have like 10 minutes. We can take some Q&A off stage. Or if you want, maybe we'll all get beer together. So thank you so much. Enjoy the rest of the conference.